Alrighty, welcome. So today we're going to be talking about radians and degrees. So as most of you know, a degree is just a way of measuring an angle. An angle is just a distance, in a sense, between two different lines. We can use it to measure the distance or the sharpness of these two lines. When we're going to be drawing angles, we're always going to be drawing the Cartesian plane, the four quadrants, and we're always going to start on the x-axis and go anti-clockwise. This is convention. So if I said to draw, say, 180 degrees, well, a full rotation would be 360 degrees, so 180 would be half of that. And that would be the spot where 180 degrees is. It's the angle between these two lines. If I said to draw 120 degrees, well, we'd start here and then we'd move into the second sector about there. It's bigger than 90 degrees, which is towards the y-axis. Alrighty? So in a standard system, we have 360 degrees in a full rotation. In the radian system, what we do is we use the radius to actually measure the angle. So if we've gone one radius here, well, it takes us one radius to get there, a second radius to get there, a third radius to get there, but we don't quite get there. And then a fourth, and then a fifth, and then a sixth, and then we need a little bit more to reach the final thing. So how could we work it out? Well, given any radius, if we want to work out the distance around a circle, we could just use the circumference formula, 2 pi r. So, in general, we can kind of ignore the radian, because we're often going to be using a radius of 1. That means the circumference is going to be 2 times pi times 1, which is 2 pi. So what that tells us is that 360 degrees equals 2 pi radians. So a full rotation is 2 pi. Well, that tells us then 100 degrees is 1 pi radians. Now, I often see a symbol to mean radians is going to be this little c. Instead of a degree symbol, we use a little c, and that also means radians. So you might see either or when talking about radians. So let's learn how to convert between them. Now we're going to be doing this tech-free, but obviously if a question just asks you to convert, you're welcome to use your calculator. But to start off with, let's go through. So let's firstly think about our conversion rate. So let's move away from these guys. If we've got 360 degrees is equal to 2 pi radians, well, that actually tells me two different conversions. If I divide both sides by 2 pi, well, that means I get 360 over 2 pi is equal to 1 radian. Or, if I want to simplify that, I could even write it as 180 over pi. Or if I instead had gone, well, 360 equals 2 pi. If I divided both sides by 360, well, then I'd get a conversion rate for converting from degrees into radians. So I've got two different conversion units. Now, I personally don't memorize these two, 180 on pi and pi on 180, because for me, the main thing that you should be taking away is that 360 and 2 pi are our two conversion units. So this is how I would do the conversions. Alrighty, so let's imagine we wanted to convert, let's go 90 degrees, that's a nice common one. So 90 degrees, well, to convert that, first of all, we'd need to divide it by 360. That's going to tell me how much of the circle we want. And since we want to turn it into radians, and a full circle is 2 pi, we multiply by 2 pi. Now some of you might go, what's that equal to? Well, without a calculator, this would be 1 over 4, 90 is a quarter of a circle, times 2 pi. 1 times 2 pi is 2 pi. 2 pi over 4 is pi on 2. And that's how many radians it is. So when we say pi on 2, that means 90 degrees. Right, let's do another one. Let's do 120 degrees. Once again, we're going to divide by 360 times by 2 pi. Convert it to radians. 120 over 360 is a third times 2 pi. Well, 2 pi times 1 is 2 pi. And 2 pi over 3 cannot be simplified. So 2 pi over 3 radians is the same as 120 degrees. And just make sure we're feeling happy. 120 degrees is about this angle here. And pi on 2, 90 degrees, well, is that angle right there. Just to make sure we're getting a visual intuition. But let's be able to do the opposite as well. If instead we wanted to convert 3 pi radians into degrees, well, what would we do? Well, 3 pi, we need to divide it by 2 pi, right? Because there's 2 pi in a full circle, and then we would times it by 360. The pi divided by pi is nothing, and then we get 3 over 2 times 360. Now, me personally, I don't want to multiply by 3. I don't want to do 3 times 360. I could do it. It's a bit more annoying. Instead, I'd rather divide 360 by 2. So I'm going to do the division first. And that gives me this. And then 3 times 180. Well, 2 times would be 360 plus another 180 is going to be 540 degrees, which would be a full rotation and then a little bit more. So it'd be the same angle as 180, but with a full rotation as well. Alrighty, and let's look at one more. Let's do 3 pi on 4 radians. So once again, we want to divide this by 2 pi and then times by 360. So let's do the division first. And then, in fact, one way we can also think about doing what these tricks we've been doing is by multiplying by where we want to go over where we currently are. And this might be a little bit easier to work out. So top times top is going to be 3 pi times 360. Bottom is going to be 4 times 2 pi. Once again, I don't want to simplify the top if I don't have to. So instead, I'm going to recognize that I can divide 360 by 4, and that would be leaving me with 90. The pi's are going to cancel. So I'm going to get 3 times 90 over 2. 90 and 2 can cancel to give me 45. So I get 3 times 45. And that's equal to 90 plus 135 degrees. Which, if we were drawing, would look something like that. So there's our different conversions. I'll see you in the next one. Goodbye.